Thank you very much for your presentation. Now, Jabrayil Eyvazov. Mr. Jabrayil Eyvazov presents us his presentation.
Thank you very much. Hello everybody, welcome to the first Global Engineering Symposium. My name is Jabrayil Eyvazov. I am Senior Reservoir Engineer at State Oil Company of Azerbaijan Republic and also a PhD student. Today I am going to talk about PVT tests, why PVT tests are very important in oil and gas industry, what are purposes of using PVT tests in oil and gas industry. As you know, there is a huge number of reservoir fluids which we withdraw from the reservoir, but in oil and gas field it is difficult to do deeply investigation of these reservoir fluids. Therefore, we need deeply analysis of reservoir fluids which we take from the reservoirs. And except that PVT analysis is very important in reservoir management. I will talk a little bit about this in other slides. And except that PVT analysis is very important measurement of solids formation and other non-hydrocarbon fluids and so on. And effects of PVT tests in oil and gas industry. Firstly, it affects the design of production facilities. What we understand when we say design of production facilities, for example, we define how to say range of condensate gas or oil from PVT analysis. We define dew point and bubble point pressures, and except that we now mixture of reservoir fluids, and therefore based on this information we set up separators. It can be for one stage separator or two stage and several stage separators. And compatibility with pipeline transport. For example, we can need, based on PVT analysis, we can need high pressure gas pipeline or low pressure gas pipeline. We can, for example, only for gas exporting, we can need two pipelines. Product sales values, refining maintenance cost, and reservoir assets in general. It is a simple illustration of gas chromatography. Based on this tool, we define component composition of the reservoir fluids. Here we inject our reservoir fluids, and there is two types of columns, packet or capillary columns, and packet columns mainly 1.5 meter in length. And here detector, there is two type detector in PVT tests, frame identification detectors, and second one, thermal conductivity detectors. Mainly for reservoir fluids we use thermal conductivity detectors. Here define, for example, percentage of methane, ethane, propane, and so on, benzol, and other components. We can divide PVT tests into three parts. First one is primary test, which we can do in oil and gas fields. It is simple test and routine test. By using this test, we can define specific gravity and gas oil ratio based on fluid sample. And second one, which we are using in reservoir engineering, this is main types of PVT tests which we are using in reservoir engineering: compositional analysis of the system, constant composition expansion, differential libration experiment, separator test, and constant volume depletion. Constant, for example, constant composition expansion, almost in all fields, we do this PVT analysis test. And differential libration tests, we do only for oil reservoirs. And constant volume depletion, we do for condensate reservoir. And separator test mainly is very important for oil reservoirs because we should do differential libration experiment and separator test together. We need this separator test for adjustment, oil formation volume factor, and gas oil ratio. And another type, specific type of PVT test is slim tube tests and spelling tests, and both of them we use to define minimum miscibility pressure and minimum miscibility concentration. First one, we will define minimum miscibility pressure and minimum miscibility concentration. And constant composition expansion, main target of using constant composition expansion test to define saturation pressure or dew point pressure. Saturation pressure, when we use constant composition expansion test for oil reservoirs, for gas condensate reservoirs, we need to define dew point pressure. Is a thermal compressibility coefficient, compressibility factor of the gas phase, and total hydrocarbon volume as a function of pressure. It is a basic illustration of constant composition expansion test. We take reservoir fluid sample from the reservoir, and we set PVT cell, and we put this reservoir fluid volume into the cell, and we set reservoir temperature. For example, it is 100 Celsius, and we set initial reservoir pressure. And here, mainly in gas condensate constant composition expansion test, we have mercury, and then in next stages, we become to reduce pressure, and here first, I'd say condensate trace will become to appear, and it means that it is dew point. And when we reduce our pressure, condensate will become to generate. And differential libration experiment, as I said, it is for all reservoirs. And for reservoirs, here also we set we take reservoir fluid volume and put in the PVT cell, and we set reservoir temperature and initial reservoir pressure, and we reduce pressure, and we take gas from the solution. And as you see here, pressure will become to reduce, and in last stage it is remaining oil. And by using this experiment, we can define gas specific gravity, gas formation, oil formation volume factor as a function of pressure, oil density, oil viscosity, and so on. And another test, constant volume depletion test, is we did this test only for gas condensate reservoirs. It is also similar illustration with differential libration test, but we use only gas condensate reservoirs. But here the main differences is initial temperature is the dew point pressure. I should mention that we use constant volume depletion experiment with constant composition expansion tests. We cannot do only one this test for gas condensate reservoir. By using constant CC test, constant composition expansion test, we defined dew point, and we start our experiment with dew point pressure, and then we reduce pressure, and you see that after reduction of pressure, gas we expand and we remove gas. And we define gas formation volume factor, liquid dropout, relative volume, gas viscosity for all pressure steps. Separator tests. It is also very important test in oil gas industry. Why we do this separator test? Main idea is to define say volumetric behavior of reservoir fluids in different separator stages and stock tank oil. We should find optimum point, optimum pressure, temperature, and operation properties to get more oil in stock tank. And it is also basic illustration of a separator test. And when we extract reservoir fluids, and here first stage, and here we take gas. It goes stock tank for gas, and here in next stage remaining oil goes in the next stage, and here also some parts of gas will be expand, and we will remove this gas, and here we find only oil, and here we can find stage gas oil ratio for here and total gas oil ratio by using these equations. It is a real project in Azerbaijan. This project was done in Tempest software, and it is CVD test. It is offshore field. This sample taken from offshore field, and as you see, our experiment starts from dew point pressure, which we find from constant composition expansion test, and we find liquid dropout as a fraction, or it can be as percent, produced moles, and gas Z factor for all stages. And it is adaptation or matching of liquid dropout. These dots illustrates real data, and this is which we adapted by changing some properties in related liquid dropout. And it is for produced moles, gas Z factor. DLE test for well number 3. It is also field in offshore, and it is bubble point pressure, and it is oil formation volume factors. For this pressure, we define gas oil ratio. This means that after bubble point, as you know, first gas bubbles will be expand, and it is gas oil ratio for this pressure and oil density. Is adaptation oil formation volume factor. In gas condensate reservoirs, adaptation of liquid dropout very important because it defines gas condensate initially in place, condensate volume, and adaptation of oil formation volume factor. It's very important to find original oil in place, correct original oil in place. It is gas oil ratio. And it is another DLE test for another wells. And separator test. Why separator test very important? As you see here, it is this temperature, in this pressure values, all densities and values, and second stage separators and stock tank. Why we need separator tests? Therefore, because we need to adjust oil formation volume factor and gas oil ratio, which we get from differential Lagrangian expansion tests. Because it is which we get from this DLE test, it is not correct one. By using these values, we cannot correctly define oil flows and original oil in place. Therefore, we need to adjust these parameters. By using these steps, and we calculate several parameters. It is, how to say, theoretical background of this adjustment. By using these softwares, how to say, software will do for us this adaptation. For example, it is a simple illustration. For example, we get solution gas-oil ratio from DLE test. And by adjustment of, by using separator adjustment gas-oil ratio, we got that gas-oil ratio should be lesser. And it is for it is for oil formation volume factor. As you see, oil formation volume factor, which we get real one, is less than from DLE test. But there is one factor that if our oil formation volume factor is less than DLE test, it means that by adjustment of separator test, our original oil in place will be higher than if we will use DLE test. Okay. Thank you very much.